Go for it.
So my name is Thomas Cordova. I'm the Vice President of PPA GLA. Big shout out to Mr. Frederick Brown, who really did the legwork for this webinar. So I'd like to give him a thumbs up. We have Farah and Simon of Woodland Hills Camera and Telescopes. And they know what they're doing over there. And we're just going to learn a little bit more about some astrophotography and some of the other things they do over there. Go ahead and take it away.
Good evening, everyone. My name is Farah Payan. I've been managing the Woodland Hills cameras and telescopes since 1986 for many, many years. And over the years, we've got the love of astronomy and astrophotography, and we got into the industry, and it's one of our main business out here. As well as, of course, doing regular photography and carrying other equipment such as lighting and
camera equipment as well.
Of course.
So just real quick, we're going to be doing a tour of our store using some of the equipment that you can actually buy from here, because we actually sell all things to do with video production stuff as well, cameras, lighting, etc., as well as telescope equipment. As you can see right now, where we're set up is the backdrops, hence why we chose something with the pretty colors, hopefully. But at some point in this talk, we will be doing a walk around of the store so you guys at home can see what the store looks like. So if you've never been here before, you're more than welcome to come along and just shop around and browse around and ask us questions. But we're going to give you a live tour, hopefully, and we're going to give you some information about some of the telescope stuff that we have, which is going to be hiding in all different strategic places. I don't know if you guys can see this camera yet, but you'll be able to have pretty much a guided tour. So Farah's going to be the guided tour. I will be the camera guide.
Sounds fair. Let's go.
All right.
Thank you. You want to start kind of showing the telescope department a little bit here, and that's where we're going to start from. As you can see, we have a pretty good selection of different kind of telescopes available, and you have to know the larger these guys are, the more light they gather and the deeper you can see. You're also now looking at different kind of telescopes, and we've taken the opportunity to set up a few things for you that shows how easily you can set up your own astrophotography hobby. You typically have a regular camera, either mirrorless or DSLR with a lot of lenses. And there is the product that you're looking at right now, which is really popular with us nowadays. Very small, extremely portable. It's manufactured by Skywatcher, and it runs with your smartphone. It's called the Star Traveler 2i, and it's super simple to use, and it's very inexpensive. You can purchase it for as little as $300. And as you can see, it's sitting at an equatorial mount. So it rotates 360 degrees every 24 hours, and you can follow any object or star in the sky and have sharp images.
And that's through your smartphone, you said?
Yes, you can run it with your smartphone. It's really simple. The nice thing about it is it's a complete setup. It carries up to about 11 pounds. And you can do your own photography without breaking the bank and get amazing images as a foreground, background, depending if you're using a wide angle lens or if you're using a larger zoom. You can pick up different objects and shoot Orion, let's say, or Veil Nebula and get amazing, or the Milky Way for that matter, and get amazing images. What we also have set up for you, which can, if you're not really, you don't feel like your lenses are sufficient, maybe a portable telescope, which is super simple. All you have to do is get yourself into a super large telescope. This particular one is actually 150 millimeter in the front element, so it gathers a good amount of light. But when it comes to a scope like that, it needs to get mounted on a more intricate setup. It needs to go on an equatorial mount. Right now, you're looking at a mount that's manufactured by Celestron. It's called the VX mount. This particular mount carries up to, believe it or not, 30 pounds, and you can image with it up to about 20 pounds worth of equipment. You can mount your telescope that we just showed you earlier, and up to that point, you can mount it onto that VX mount, and then purchase a really cool camera, like the red camera that you can see right now in Simon's screen. It's called the ZWO camera. These cameras are typically cooled, unlike the regular cameras. They're also super sensitive in H alpha, and they're far more sensitive than the regular cameras that we use. So if you get a 10-minute exposure and you can see a deep sky object, this can probably do it for you in a fraction of a time, like maybe in 2 minutes. Now the nice thing about these cameras is that they come in monochrome or in color. You can do one-shot color. They're super simple to use and they're not complicated, but they're not quite as sensitive as monochrome cameras. You can purchase them in monochrome, but at the same time, you have to get yourself into a filter wheel and put different kind of filters in there. You can put the primary color of red, green, and blue.
Oh no, Sarah, I think you muted yourself. There we go.
Objects that you shoot, okay, they can have oxygen 3. They can have H alpha if you're shooting salt, or they might have sulfur. They call it S2, and you add these filters, so you get exaggeration of those colors as well, and you get more data actually imported. If you want to learn a little bit more, a very popular book is Backyard Astronomers that talks all about imaging, and it talks all about what equipment you need in order to take beautiful pictures. It doesn't cost a lot of money, but it will teach you a lot. Something that just happened, the annular eclipse. I'm not sure if you had an opportunity to get yourself into a solar glasses and look up. That's something you can do with a telescope called an H alpha or a solar telescope. These solar telescopes are amazing. They start up at about $800 or $900, but you can see solar flares, you can see granulations, and you can image all of these and get really amazing images. We have a picture in our store that Simon is going to try to see if he can show it to you without the glare. You can see a bit of a glare on the side, but you can probably get a better idea of how amazing these images can be of the sun through that particular telescope and the camera that we showed you.
How strong is that telescope, Farah?
That particular one, the very first one in red that we showed you, it's not very expensive, but it's extremely powerful. It's really ideal for planets. What happens is that planets are bright and they're really close to us. So you can shoot through that particular one and get a lot of details on the planets.
Oh.
The key is to be able, because we move so quickly, the key is for you to get a camera that shoots really fast. Some of the cameras that we sell, they can do 100 or 130, 40 frames per second. It doesn't give you the same resolution as you expect, but you're never going to print these images. You're going to see them on the screen, and that wouldn't make a difference. But it gives you so much detail because it gives you so many frames per second. We have a lot of different cameras. There's tremendous choices when it comes to different style of cameras that are available. This is just one brand. They have different size chips, small or large, monochrome or color. and of course, cooled or non-cooled. When you do them cooled, you can do longer exposure. The new technology allows you to do live view, and because they're so super sensitive, you can just project them onto your home screen and share your brand new hobby with your family, which is kind of fun.
Is there a price difference between the monochrome and color?
No, there isn't that much of a price difference, but when you shoot monochrome and if you're looking for that wow factor, you need to get yourself into a filter wheel, which costs extra, and of course the filters, which cost extra. But it gives you a lot more details because it is more sensitive than a colored chip.
Hmm.
Green tea.
If you have any questions, actually Simon is an imager and I'm sure he'll be delighted to answer.
Okay, we're just going to give you guys a quick a rundown of the entire store real fast, okay? So I'm going to start from this side and I'm just going to work my way around. Okay.
Sounds good. We're going to start with our camera department here. As you can see, we have pretty good selection of lighting as well as stands and tripods. And of course the accessories, again, more diffusers and different kind of lighting equipment, more tripods, and of course the accessories of all kinds, which is kind of fun to have. We sell papers for darkroom as well as digital. We have, believe it or not, film, and we process them, which is really cool. They're the popular stuff nowadays. All sorts of batteries, and of course, I think he's going to go to the filters in a minute. So you can see we have a pretty good selection of filters, of all sorts of other accessories. And then our camera department, we do a lot of used gear in film as well as digital, and the nostalgic little point and shoot cameras. And as well as, of course, mirrorless cameras, but I think he's still showing you our beautiful Leica M10 monochrome there a minute ago, which we're really excited about, and it's really a good deal.
Hey, Farah.
There's memory cards. Yes, sir.
Do you, for your telescopes, are there different mounts for different camera brands that you carry?
Lots of different brands of mounts. Depending on how much weight you want to put on a mount, the price would vary. So one thing is for sure, it's the rule of thumb for a starter. If you're purchasing a mount that you're going to put a heavy telescope on and you want to do photography, you have to purchase an equatorial mount. That's for the beginners, of course, but as you get more advanced, there are different systems available. When you go to a larger telescopes, there are derotators that would allow you to do long exposure and they will compensate. But if you're looking at $800-900 or $2,000-3,000 or even up to 10K, there are equatorial mounts that you can purchase, and you can put as high as 200 pounds worth of light gathering giant telescope as well as camera gear on it, where it really cuts down your exposure time for different objects that you shoot.
Okay, so let's open it up for questions, I guess.
Folks, there's a chat, but if you look on the bottom of your Zoom, there's you can either use the chat function or the Q&A section and just type your questions in and I'll get them answered.
So how long have we been here in this particular location for now while they're doing their questions?
Actually, the store has been here since 1952, but we moved out to our brand new building in 93, and we've been here for the past 30 years.
And you've always been the owner?
Time, huh?
Right.
No, actually, I took over the business in '86. I've been lucky.
Oh, well, you've been there for a while.
Yes.
Yeah.
I think one of the best things about our store compared to a lot of other telescope places and even camera stores in general is for the San Fernando Valley specifically, we are literally the only camera store left on this side of the valley. And then when it comes down to telescope stores, we are practically the only telescope store left in the whole of California to a certain extent that is open to the public. You still have a couple of other places dotted around in different places, but they're not necessarily accommodating to just walk-in customs. So a lot of times you have to have an appointment. This store, we have no appointments. You just simply come on in. So there's always going to be somebody here, either myself or Victor are the two guys that do the telescopes. Of course, if you guys call in on the phone, there are other people that service because, you know, they're all in different time zones. So we can service as many people as possible across the different time zones.
So yes, one of the questions I understand was, can you mount your DSLR or your mirrorless camera to your telescope? Of course you can, absolutely.
It's actually, I was going to say, it's actually quite straightforward. It all depends on your camera. So the important thing is you just need to know if it's a Canon or a Nikon, if it's a new one or an older style one. And the actual connector you need is something called a T-ring. So the T-ring is unique to the camera, and then something called a T-adapter, which is nothing more than a nose piece that goes into the telescope.
Can you get a better result shooting the sun with a Mylar solar filter or a H alpha filter
Okay, so those are
or a
two
DSLR system?
right. So those are completely different things. Let me go through the different types of solar first of all. So let's talk about white light first of all. That is probably the cheapest and easiest way to get into doing any type of solar photography, and any camera actually works for that purpose. Depending on your telescope or your lens specifically, the longer the focal length, the better the resolving power is going to be and the more you'll actually see. So if you're looking at something like sunspots, for example, you actually want as much focal length as possible, or the biggest aperture possible with whatever the solar filter is, in order to resolve any kind of details on a sunspot. If you just have a standard lens, like say a 200mm with a solar white light solar filter, it will appear nothing more than just a black blob. But if you look carefully, you will see things around it, but they almost look like tendrils is the best way to describe it. Now that's specifically for white light. If I do something like hydrogen alpha, on the other hand, or H alpha for short, that will show you something completely different. White light shows the photosphere, whereas the hydrogen alpha aspect is the chromosphere specifically. Most people mistake this as being the surface of the sun. It is not. The chromosphere is actually part of the sun's atmosphere. In fact, there are actually 4 major sections. The corona is the biggest part that we can't actually see. The only way you can see a corona is during a total eclipse. And then the chromosphere is the next layer down. That's the one you see in hydrogen alpha. And the best way to describe it is it just looks like swirling clouds, is the easiest way to explain it. The photosphere is your white light. And then you have something called the convection zone. Unfortunately, you can't actually see into the convection zone because of the photosphere and the chromosphere being in the way. But those are the 4 major layers of atmosphere on the sun. And keep in mind, there's no actual surface on the sun, so don't think we can step down on it.
Hey, Simon, with that photo you showed,
Yep.
up on the wall, can you tell me the basic exposures, what their exposure was to get that type of photo of the sun?
So that particular photo that you saw earlier on is part of the chromosphere. In fact, we were looking at a sunspot to be exact. In order to get an image like that, people think you do long exposure. It's the complete opposite. It's as fast as possible. It's a reality behind it. So that particular image was shot with a 12 milliseconds. That's really, really fast. 12 millisecond exposure time. And in terms of what the ISO is, there's no actual number that we use for it because we don't measure things in ISO. We measure things in gain is the number. And the gain setting is actually set to around about 150 specifically for that shot. But the exposure is only 12 milliseconds.
But is it only one, or are there multiples?
So that's the great question about it. What we actually do is we take multiple shots. So in that 12 milliseconds, we will, well, sorry, not the 12 millisecond, in say 1 minute, we're going to try and take 1,000 images. And out of those 1,000 images, we're going to now pick out the best 50 images. And those 50 images are then stacked to be able to create the image.
Oh,
In
interesting.
other words, is essentially 50 12 millisecond exposure.
To combine it together to make a final image.
And that way you can see the granulation, the flare, the sunspot, correct, sir?
Yep.
There was a question about shooting in the city. That was really the older technology. What's happening right now, there's so many amazing filters out there that you can shoot deep sky without having to leave the light polluted city.
Oh, really?
Yeah,
Oh,
we actually refer
absolutely.
to these as narrowband filters. Now, traditionally, when you say the word narrowband filter, most people think of monochrome cameras. By today's technology, they've actually found that modern cameras, and you do have to buy a modern camera for this to work, is they're able to see into the infrared spectrum and ultraviolet spectrum better than what older cameras can do. So we now sell these filters called narrowband duo filters, which actually only show up hydrogen alpha and oxygen 3. You can get other ones with different combinations, but the most popular is H alpha O3 specifically. And essentially, all it does is takes images of the red and the blue channel, and the green is simply ignored.
So in other words, you can shoot anywhere, literally.
And the thing is, though, this isn't like some marketing gimmick or something that people make up, like, you know, here's a science paper. This is real. This really does work. I have a customer who literally lives 10 minutes away from here, and we are slap bang in the middle of the valley practically, looking through LA on top of that. And he uses this one filter, and the results he gets are just unbelievable. And we're talking 2-3 minute exposures here. We're not talking long ones.
It will be. Oh no, go ahead, Simon. I'm sorry.
I was going to say, the only difference here is it does have to be a modern camera. That's the most important part of it. And what I mean by modern camera is any of the mirrorless cameras, especially the ones that are back illuminated sensors.
Will the tracker track the sun to shoot the time lapse of the next eclipse?
Oh, yes.
Of course.
All
Totally.
tracking platforms can track any celestial object. It doesn't matter what it is. You can actually even set them into custom modes if you want to even follow a comet, because there is actually a comet coming up here soon.
Yeah. Oh, that'd be kind of cool. That photo that's up on the wall of the sun, what kind of camera did you use to shoot that? Do you know?
That's actually a monochrome camera. It's one of those ZWO cameras, and they're actually quite small and compact. Believe it or not, the size is actually smaller than Micro Four Thirds. And the reason why we use these small cameras is because we're trying to get a high frame rate. So this particular camera is designed for 230 frames per second. And it's quite critical that we capture this, because a lot of people don't realize this, but everything that you see out there rotates, including the sun, believe it or not. And the last thing I want to do is capture data to the point where too much rotation has occurred. So when I combine these images together, I do not want to combine rotated images or rotation of the sun. So the idea here is to shoot as fast as possible in that time frame. So obviously with 12 milliseconds, you are somewhat limited to how much you can capture within a second, which is approximately 103 frames. I only know this because I do this for a living. But if you're doing other things, because my personal favorite one is doing International Space Station, you're doing like the transit, you can actually set this camera to do 230 frames per second, which means you will literally catch this ISS going in slow motion. Keep in mind, the average time it takes for the ISS to cross in front of the sun as a transit can be anywhere between, say, 2 seconds to 0.6 of a second. So your shutter speed needs to be able to accommodate that type of speed. You can only get that through these astronomy cameras. You can actually go, if you want to go photographic terms, 1/8,000th of a second if you need to go that fast. Most cameras can't even do that. Whereas these astronomy cameras can go down to like decimal points. You can have the shutter open because they're electronic at like, say, what, 0.3 of a millisecond? We're talking microseconds now, not milliseconds, microseconds. That's how fast they are.
Indeed.
Yeah, what's the software is needed to process images and stacking?
I can list them out. So if people want to do some research, the capture software that we like to use is a program called SharpCap. or fire capture. Those are the two capturing softwares. The stacking software is Auto Stacker, and the processing software, you can either use something called Registax or IMPPG. Either or can do deep sky, solar, and planetary. Now, if you guys at home who are watching this, you can always check out our YouTube. Just go to YouTube and type in telescopes.net into the YouTube search bar, and we will pop up. And we actually have hours and hours worth of content, including tutorials, demonstrations, and product videos on everything that we sell here.
As well as how to shoot, actually.
Yeah.
No. Are there any filters that we can use to cut light pollution without cutting the clarity of the stars?
Yes, there is. Probably the best, like I said, the best one that we've been selling is that narrow band dual filter made by a company called Antlia.
How much are those filters?
Well, 360-ish, give or take. So
Okay.
they can range anywhere from as high as 400 or 500. You can get the lesser expensive ones. It depends on how good your skies are. If you're in a relatively good sky and you know your rating, we'll call it, say, like Bortle 4 and 5, you can get away with the other filters, which are not as constrictive. So keep in mind, the narrower the band pass gets, the more expensive they become. But the wider the pass gets, the more inexpensive they are. They're basically a lot more affordable. So if you are trying to image in the heart of a city, you have to get the very narrow ones, which are around about 3 nanometers in terms of how much band pass they have. But when you're out in, say, like the suburbs, you can get away with 7 nanometers. But let's just say we got out of the city, we can get away with 12 nanometers, which at that point, they're literally like $160. So they're really, really affordable.
Nice. So either you spend it on gas or you spend it on a better filter.
Exactly. That's the funny way of looking at it. The other guy who works here, his name's Victor. The way he explains it to people is, would you rather spend $50 in gas and drive 500 miles away, or would you rather spend the extra $100 and stay where you are and take pictures from where you are?
Yeah, that makes sense, doesn't it?
Yeah. Well, it depends on where I'm going, you know. It might be
Well, that's true.
Hey, is it possible to kind of show us how to set up a telescope with a camera? Do you have anything on hand?
Is that a camera back there? These are pretty simple threading. It's nothing complicated, really.
Yeah, I'm sure. Kind of. Yeah.
Yeah, it's 42 millimeter thread, and it goes into a camera adapter that's already mounted onto the. Are you referring? Maybe I should back up for a second here. Are you referring putting a mirrorless or a DSLR on a camera, or are you referring to more sensitive cameras that we sell to be put on there?
Well, either or, really. I think most, I would say most of us have mirrorless and DSLRs, but
That's a little bit. It needs a couple of adapters. We weren't prepared for something like that. But
yeah,
if you want to
just
get
asking.
a more sensitive camera that we were showing out there, it's really simple.
It's actually, there's a nice way to simplify how this connects. If you can imagine any of your long telephoto lenses, it's really as easy as grabbing one of those and putting your camera in and just clicking it on.
Yeah,
It is.
right.
It's
exactly
a click
the
on
same
its
thing.
bayonet.
Yeah. Okay. Oh, what's the strongest telescopes you got?
How much money do you have is the real
That's
question.
right.
That's what I usually say. No,
24 inches is what we have in stock. It's huge. It's actually, it's about 100K.
Oh,
I mean,
wow.
don't get me wrong. We have access to pretty much any commercial telescope that you can possibly lay your hands on out there. In fact, we actually sold this quite recently, and this was not to a professional. We even sold a radio telescope to somebody.
That's right.
Up in, where was he? He was up north somewhere near Michigan, if I remember correctly. And the great thing about radio telescope is it does not matter about the time of day or the weather, because radio goes right through clouds. And that's how crazy this actual setup is.
Yeah.
So a customer wanted to do something very, very different, and I introduced him into radio astronomy. And once he actually saw what this whole thing was, it was nothing more than a satellite dish. What you're really buying is the simplicity and the software behind it. And this is the radio to space products from a company called Prima Luce Labs out in Italy. And those guys are going to be here next week, hopefully. They basically made it so simplified that you can do this from home. Now, obviously, they sell different size antennas as what they're referred to as, but the average one between me and you and most other people, a 230 millimeter antenna is more than sufficient. And you can pretty much point it anywhere in space and start doing radio astronomy at any time of the day. But that's a whole different thing. That's radio astronomy.
There's a lot of science behind it. So if you're really honestly interested in the science end of it, you can get into spectroscopy, photometry. You can go to different objects to figure out what the objects are made of, and you can do so much with the hobby of astronomy.
Yeah,
It's
you can get
really
real
wide.
deep in it. I'm a simple man, Farrah, so I like to keep things simple, but I'm sure there's people out there that would love to dive into it. So
Well, the one thing about this hobby here is, and this is what happens to a lot of our customers. So we'll go as if you guys just came in. So we'll get you interested into the hobby and start taking pictures. The big part of it here, and not everybody does this, if you have that aha moment and something clicks inside of you and you start asking more questions,
Yeah.
a lot of it will lead you down the sciences. And we've had countless customers who walked in this store, they never thought about doing science ever. And the next thing you realize is we see them a year later and they go, I need this, 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 and this. And I'm like, hold on a second, when did you get into photometry? It's quite amazing how they got into all of that.
would you say a mirrorless camera is better for astronomy than the DSLR?
Okay, the easiest way to answer that is that there's really no real difference.
Yeah, and quality-wise?
The only time it makes a difference is if you're buying a modern camera versus an old one. So, for example, if you have like one of these old Canon T3s, for example, and you bought something, say, like a Sony A7C, which is like one of the latest cameras, no, the technology is completely different. We're talking like the 15-year technology gap. Of course, the Sony is going to be a lot better. Just because it's mirrorless, however, doesn't make it superior.
Correct. The difference comes when you kind of walk away from that system of mirrorless or DSLR and get into the more advanced cameras that we sell that are
For astronomy.
for
So
astronomy.
the dedicated astronomy cameras are completely different. Some people who do the research behind this will discover that some of the cameras that you use for astronomy purposes are the same sensors you find in a Nikon camera. The thing is, though, there are modifications that have been done to these sensors to be more sensitive towards the infrared specifically. More importantly, they've all been converted to be electronic shutter as opposed to a mechanical shutter. Almost all mirrorless cameras and digital SLR cameras have some type of shutter system that's mechanical. And it's not a bad thing. It's just that's how the technology has evolved to use an electronic shutter. It's actually better in order to get these really high frame rates if that's what you're doing. Long exposure, it's not so important.
Yeah. Hey, can you walk me through getting started with a Canon R5 and with my 7200 2.8 using the basic tracker?
Oh, yeah, it's actually very, very straightforward.
Yeah, that's a perfect system for it. For $300, you get a Skywatcher that we showed you earlier. He's gonna go get it so you can see it close up.
Let's check it out, Simon.
So this is it right here. So this is basically the actual guiding mount. Like I said, all you literally do is you attach the camera and the lens up on this section here. You do what we call a polar alignment, and you do have to read up on this. And all it means is, assuming north is going that way, this axis is pointing directly at the celestial North Pole. Okay, and I'm saying that specifically, not necessarily Polaris, because over time, Polaris will no longer be the North Star. So as long as this points at the celestial North Pole, this thing, I just disengage the clutch, will actually turn very, very slowly and track the apparent movement of the stars, no matter where this camera is pointed. So I can make the camera point, say, over here. And then as this thing tracks, it'll always be looking at the same thing.
Huh.
But it's very, very straightforward. You can see there's nothing more than it's just bolted on. It's just the camera.
What's the model number of this guy? Is S2?
Oh, this is the Star Adventurer 2i.
And you can purchase it at telescopes.net.
or you can come in, preferably come in.
Yeah, that's pretty much my level right there.
But you'll be surprised. Once you get the hang of this, you can outgrow these things in less than 3 months. And it happens to every customer that walks through our door. They'll start off with something like this. They
Yeah.
grow out of it. I usually tell people keep a hold of these things because when you get into the hobby, 2 years later, you may come back and go, I wish I still had this mount. And it's funny because this mount specifically, I can sell to the same customer twice in his entire lifetime because he would have gotten rid of it the first time round and then decides to do something else and goes, damn, I need that mount again. He's back here a year later and says, I thought I sold you one of these. And he goes, yeah.
You know what's amazing with this is that if you put a wide angle lens on here, instead of a 70-200, a wide angle lens, and if you're in nature, it gives you the foreground of Earth and the background of the sky. And it's the most beautiful image you can imagine.
Oh, that sounds cool.
Oh yeah, you could do a lot of landscape photography with this as well. In fact, a lot of the there's a Japanese guy that uses this exact system, and he does these awesome time lapses. What he did was he put this mount on an actual moving platform, and when he's actually using it, you can actually see the distortion occurring. But he's gone out of his way to do the rule of 500. So he's worked out how many exposures he can do, even if this thing is slightly moving with some parallax. And he can actually get really good shots with it. So he actually works it out. If you actually scrutinize his pictures very carefully, you can actually see a tiny bit of trailing where it's moving out of alignment when he's doing that. It's a Japanese guy that actually does this with this actual tracking mount. And it's incredible the results he gets.
Huh, that sounds crazy.
And he's also using a Fujifilm camera as well, but I'm not going to go into that too much.
Well, whatever.
It's just a mirrorless camera.
Yeah. What's the limit on the I'm a stutter. I can't say this word. Can you see that bottom question?
Magnitude? No, I lost it. Hang on.
Yeah. I don't know if you can see the
The
webinar.
limit of the magnification on analog, real, optical images and digitally
Enhanced radio
captured.
photos. Oh, okay.
There you go.
Well, technically there is no real limitation. The only limitation is just based upon your telescope at the end of the day. It depends how you want to get into it. Let's just do this by the nerdy way of going into optics. If your pixel size matches your telescope, in theory, you can actually have the same image scale, if that makes sense. That doesn't mean you get more resolution, however. So it scales up by aperture. The bigger the telescope gets, the more the resolving power. And by nature of the beast is your focal length increases with it. So it doesn't make any difference what you're trying to capture. If your aperture is big enough, you can do whatever you want. Same thing with a radio telescope. The bigger the antenna, the better the resolution. When I say resolution, I don't mean the camera's resolution. I'm talking resolving power. Are you guys familiar with that phrase, resolving power?
I'm not.
Okay, I'm going to explain it in a very, very simply bad way. Think of a penny, okay? In fact, let me do it this way. So I've got a QR code here, okay? And this phone has a tiny, tiny little aperture that simply cannot resolve this. In fact, you can't see this. Now, if I get closer to the camera, the more likely you are to see it. And this is what we're referring to resolving power. Now, if I'm back here and my aperture is 5 times larger than it currently is right now, it's as if this was here, but I'm still all the way back here. That's what resolving actually does. The bigger that aperture gets, the easier it is to resolve something from further away. That's resolving power. That's all to do with the aperture. When I say aperture, I'm not talking f-stop, not like f2.8 or anything like that. The aperture is the front element. I'm just going to grab something. This is a telescope we were looking at earlier. This part down here is what we refer to as the aperture. This opening here, from here to here. So this is 150 millimeters. The bigger that gets, the better the resolving power. Does that make sense?
Yeah. Yeah.
If I lose you guys, I do apologize. Like I said, you're more than welcome to physically come to our store. We do have some practical demonstrations to a certain extent that we can show you as well.
Can they can they email you, Simon?
Of course, you can always email us at orderinfo@telescopes.net, or just email me directly, simon@telescopes.net.
Hey, Simon, that tracker, it was for $300, correct?
Yeah, you can. They start from $300. That's probably one of the more popular ones for the larger style systems. If you have small point and shoots, the best one is actually the Star Adventurer Mini, and that's the cheapest one out of the entire group. I can't remember the price off the top of my head. There you go, $235.
Mm.
And I have one of those too as well. I kind of have every single one of them because I'd like to do multiple things.
Yeah. No, that 300 tracker seems pretty cool.
Yeah, I've actually seen, and this became a recent popular thing, is a lot of people started using the Star Adventurer Mini to put their phones on it. So you have the Star Adventurer Mini, and then they put their phones, and they actually do long exposures with their cell phones, believe it or not.
Oh, really?
Oh yeah, it's become a thing out of nowhere.
Yeah, everything's coming out of nowhere when it comes to phones.
Again, of course, we sell them. We sell the phone adapters, etc., etc. Like I said, all you got to do is just come over here.
Do you have used or traded telescopes?
Yeah, we do trade-ins as well, actually. Obviously, we don't buy absolutely everything. It has to be in working order, but we do buy all sorts of weird and wonderful things.
Okay, cool. Cool.
There was a question earlier. Do you do classes for amateurs?
Yes, we do occasionally. So other than the stuff that we do online training on our website, we do have ways to set up things in person. So either myself or Victor, there is obviously a charge for it. We can do one-on-one or we can do group settings depending if we get enough interest. Normally we end up doing with individuals one-on-one. So we'll teach people the basics, setting it up and getting it up and running. I will stress this though, we don't do installations where we set it up and then off we go and then it's all automated. That's a completely different service. So if you're looking for like one-on-one tutoring, ideally come to us with what it is that you want so we can create a program around it. And then obviously the price will be according to what you're trying to get out of the whole thing. Sometimes we actually go out into, I think the next one is Borrego Springs. It's called Nightfall. That's right. Which is a star party in Borrego Springs. As far as I know, it's a free event. And it goes on a Saturday, was it Thursday, Friday, Saturday, and it's in November. If you just Google or do a search for Nightfall Star Party, again, it's in Borrego Springs, so make sure it actually says that. And you literally just show up and they have all sorts of weird and wonderful things set up. They have all the telescopes at nighttime. This year we have Fujifilm that's going to be there. We're going to be doing long exposure nighttime photography. And then during the daytime, there are classes throughout the entire event. I usually do one or two of them as well, but it kind of depends on how many guest speakers they have. I think this year is absolutely jam-packed, so there's so much happening. I think the best thing is to do events like that.
Is the Comet the next thing that's coming up?
No, the next big thing, because there's no guarantee that this comet's going to show up, unfortunately. The next big thing is actually April 8th is the total eclipse.
Wow.
That's the next big thing.
It's
Not barring any other random disaster.
It's going to be visible from
It's
from
actually going upwards, okay? Everybody seems to think it's going to cross this way down from east coast to west coast. It doesn't work like that. It's west to east, okay? Just remember that. It starts from the lower end and works its way up. So you do need to be in key areas, specifically parts of Texas, all the way up to New Jersey and New York. If you're lucky enough to go to South America, you can watch it from down there. I think majority of people are planning to be in Texas, but I'm not 100% convinced by the weather. To be totally honest, you could be almost anywhere in the US. You won't get totality, but you will get a percentage. Like for the one that happened just recently, we had an event in the back of our store where we had 76% coverage. And it was actually quite a great experience. You actually felt the experience behind it. And a lot of people actually pointed out it was actually cold in the morning. I said, it's not normally like this. It's because we're actually having the annular eclipse. We're receiving 76% less solar energy right now. That's why you physically felt it was colder than it really was, even though the temperature says something otherwise.
Interesting.
All right. Any other questions, dare I say?
Yeah, we'll give them a few minutes here. Oh.
Someone's asking, can you list the apps again? They missed it.
Oh, yes, the apps. SharpCap or FireCapture are the two capturing software. The stacking software is AutoStacker, and the processing software is either Registax or IMPPG.
Nice.
There is other software as well that you can use. I think the current one that we use right now for nighttime photography is something called Nina.
And what's the basic ND filter needed for the?
Okay. I'm glad somebody actually asked this about. You can't use standard ND filters. The type of ND filter we use is actually ND 10,000. Sorry, ND 100,000. So it's actually quite extreme. You can't just combine a bunch of filters together. It still doesn't work. You don't actually lose enough stops is the real problem behind it.
And,
So the type
and to protect your eyes as well.
Yeah, the thing here is though, obviously your camera is your camera, but if you do this visually, you have to be very careful. The type of filter that you use has to be rated for visual purposes. So when you're buying a solar filter, if you're not buying it from us, especially if you're just doing this online, triple check what type of filter this is. It'll say photographic or visual. Those are the two key words. If a filter says nothing and it just says solar filter and it's $20, do not go anywhere near it. The chances are it's not a real one. There's a lot of these duds out there that I've come across that are unbelievable how they could even get away with selling them. You have to make 100% sure they're from a reputable company. An example of some companies is Barda, Daystar, Thousand Oaks, American Paper Optics, American Paper Products, Rainbow Symphony, and of course, anything we sell, we've already vetted to make 100% sure.
You said ND 100,000?
Yeah, I think it's ND 100,000. I'd have to double.
That is correct. It's actually over 16 stops.
You know, wow. Do you know the price range for like an 82 millimeter to 95 millimeter?
Oh yeah, they're like 130 bucks. They're not expensive. They're not meant to be expensive.
I don't know.
I saw something about welding glass. The answer is no, you still can't use welding glass. It's still not safe.
Oh, really?
Yeah, it is still not safe. Most of the solar filters we have are actually currently in stock. In fact, we still have 77 millimeters, 86. I believe we got a couple of 95s. Do we have the small six? We got 67.
58 and 67. We have everything.
And again, it's not like there's some massive shortage. We could actually still keep ordering more if we need to. So yeah, 77, 86, and 95, we have access to all three. We have them here right now.
Can you discuss shooting Aurora Boreals?
Oh, yes.
Yeah.
For those of you who have never seen the Aurora before, and it's actually a big shock to everybody, when I say the Aurora moves, it moves. You can watch it change in real time. The actual trick about shooting Aurora is not long exposure. It's high ISO is the actual answer to that. You need you need the fastest lens you can possibly get. In fact, when I was doing the walkthrough, you guys probably spotted a 50mm f1. That is like the ultimate lens for doing Aurora. The reality is it's a fast shutter because it moves so quickly. And I think a lot of people are always stunned by how fast it moves. They're never ready for it. They stand there and go, we thought it was this really slow moving curtain that just flaps around occasionally and it kind of moves and slow. Nope, it is moving. It's like watching a storm rolling through is the only way to describe it, but it's just like a color light show.
Oh, I had no idea.
The actual trick is You want the fastest possible lens that you possibly can get your hands on, and you want to really crank up that ISO. Obviously, for those of you with modern mirrorless cameras, you can do 3200 ISO and still have a really nice clean image. If you're on an older camera like a 5D Mark IV, you need to go to like 1600 ISO, but you've got to get at least an f2.8 lens on there.
Yeah, those ND 100,000 filters, do you have those on stock, or are they
Yes,
smaller?
have those in stock.
Yeah, you got them like 77 millimeter, 86, 95.
Yes,
As well as 58 and
67.
67. We have most of the size, and if we don't have the size you're looking for, we have step ups for them.
Tripod size recommendations, variations, or for recommendations, vibrations.
Tripod. Well, here's the funny part of it here is set your tripod to as low as possible is the answer. Get it as close to the ground as possible. In fact, the tripod is not the critical problem. The mistake everybody makes is bringing the tripod as tall as it can possibly go. That's actually the ultimate mistake. The reality is get it as low as possible. So at that point, any tripod works.
Earth rotation speed.
I'm not a scientist, so I don't actually know the answer to that one.
Yeah. I was like, oh, I don't know about that one. So when you're doing star trails, is that the Earth rotating, or is that the stars moving?
Okay, so that's actually the Earth rotating, not the stars moving. Now, keep in mind, yes, do stars move? The short answer is yes. But from our perspective, we simply cannot see any type of movement. But for star trail rotation, then no, within 5 minutes, you can get a really good star trail. It just depends on how wide your field of view actually is. If you're trying to get really nice looking, like perfect circles, you actually have to do multiple nights, unfortunately, because the problem here is during the daytime, you can't see the stars any longer. So you kind of have to try and get as many nights as possible to do this. But what a lot of people like to do when they're doing the star trails is they'll take loads of 5-minute exposures, and then they combine it in something like Photoshop in order to make this gigantic streaking trail. Some people have tried it by doing 1 hour exposures, but the smallest problem can ruin the shot. Either somebody driving in through with a car, somebody bumping the tripod. That's why a lot of people don't like doing the 1 hour long exposure. You simply do 5-minute exposures, take them into Photoshop, stick them all together on a layer, and then you just basically do, I think it's a soft light is the setting for each individual layer, and then it just combines them all together. You can also average the images together. There is a function in Photoshop where you can do that as well.
Does temperatures on the cold nights change the focusing of the lens?
Yes, of course, always. Acclimation is a huge thing, not just in telescopes, but also camera lenses. So as you can imagine, as the colder it gets, everything contracts. And this is a very well-known problem, is when you're actually using any equipment, and it doesn't matter if it's a telescope or it's a camera tripod, by the end of the night, everybody always notices everything is incredibly loose. It's because all your stuff has contracted because of the cold. So you do have to keep an eye on things like that.
Let's go. We got another question here. Let's see.
There's the next one. If Betelgeuse went supernova, would we be able to see it via the naked eye?
Oh, easily. You could even see it during the daytime. The chances. So here's a crazy thing about all of this. The chances are Betelgeuse has actually already gone supernova and we wouldn't know. It's so far away that the light takes so long to travel to us. In fact, when we're looking at any of the stars up there, and we'll do a simplified version of this, if a star is 10 light years away, we're looking 10 years into the past. So what that means is if something happened to that star, we won't know for another 10 years until the light gets to us. To make it a little less extreme, let's look at the sun, for example. anything that happens, let's just say the sun exploded, we wouldn't know for 8 minutes because it's far enough away that it takes light 8 minutes to get to us. So the chances are, if Betelgeuse has gone supernova, which it's probably likely has because it's already in its final stages of its lifespan, it would have gone supernova, but because of its distance, we simply won't know until that time comes. There's no actual way to detect it because it's just the distance is just so severe that there's no way for us to actually tell. There was a moment, and I think what you're referring to is during, I think it was 2020 or 2021, Betelgeuse had dimmed dramatically. Now, scientists have done all their research. They've done photometry, spectroscopy. They've done everything, but they couldn't understand what was going on because there was such a big dimming of the star that it actually shrank in magnitude for us. And it lost its position as being one of the brightest stars in the sky. In fact, it went from 5th position down to like 8th position or something crazy like that. And then all of a sudden, it just went back to its regular magnitude again. It was almost like something happened or something passed in front of it, but there's no way to confirm any of that because the problem here is we just simply don't have any earthbound scopes that were looking at that time to be able to resolve that detail. So the people that were looking and monitoring at the time, they have radio telescopes that were staring at it, but they weren't looking for it. So that was the biggest problem. They recorded the data, but they have no idea what that was. The problem is we can't monitor these stars 24 hours a day, 7 days a week. To a certain extent, that's where people like you, me, and everybody else that get into astronomy, they rely heavily on us to see these things. In fact, most supernova discoveries across the sky is not done by a professional astronomer. It's actually done by an amateur. We are generally the first people to discover something like a supernova way before NASA does. And I'm not exaggerating. NASA doesn't stare at these stars all day long. What they do is they stare at a tiny patch of sky about this big all day long, and they'll just leave that scope pointed in that direction for months. They don't have time to look here, there, and everywhere. People like you and me, we do all of that, believe it or not. All right. Are we getting close to wrapping up?
I think
I
so.
think-
Yeah, you want to
so.
close it out, Thomas?
Yeah, no, I think we're good. Yeah.
All right.
Well, hey, Simon, thanks. Appreciate
Yep.
it, Farrah. Thank you very
Thank
much.
you guys very much.
Yeah, thank you for having us here. If you guys ever want to do this again, we're more than happy to do this again. Of course, we invite you to physically come to the store and check out all our fun things, and obviously check out and find out if there are any events locally as well. So most of the times we know what most of the local events are going to be and where they're going to be. Best thing is to do is just simply call us or just come into the store and just check out what's going on.
Do you have any websites or anything like that, Simon, that you put all your photos over, Farrah?
Telescopes.net.
And whcamera.com, of course.
Yeah, almost everything you can ever think of, because we have blog posts. We have our Instagram that's on there. Our YouTube links are all on there. Everything you need to find is on telescopes.net.
We also are probably one of the very last really premium labs in
What's the price of
the
that?
valley. Darkroomlab.com.
Somebody's asking for the price of that M11 or M10.
M10 used
With the 35, how much was that?
with the third.
It's a monochrome camera, remember that.
It is an amazing camera. It is a monochrome camera, and I think we're selling the complete setup for very little money. I have to look it up, but I think the camera is like new in its original packaging all the way through, and it's has maybe just a few shots on it, no more. It's essentially new, and it's selling for $6,000, and the lens is selling for $1,800 if I'm not mistaken. He's looking it up just to confirm. It's a great opportunity.
Yes, since we got a few minutes, just want to let everybody know that I really appreciate the PPA-GLA board. Really excited for next year. We'll be doing a lot of more things like this, so stay tuned.
Okay, an M10, it's 6,800 for the camera and 27 for the 35. If you buy them both together, I'm sure we can come up with something.
Sounds good. One more time with your email if anybody has questions for you.
Simon@telescopes.net. Anything to do with sales, you can obviously contact myself. If you need to speak to Farah for any reason, it's just Farah, Farah @telescopes.net.
As well as whcamera.com. We answer to all.
Yes, we do. The easiest way to get pictures printed is just to simply email us the pictures, and we can print them all day long. I'm just going to give you the email directly. It's just Kurt, CURT @telescopes.net. Yeah, we can. He does.
Yeah. You can also go to darkroomlab.com. You're gonna love our work.
Yeah, I'll be checking that out myself. I've been wanting to get back into film.
Yeah,
Stuff.
come on in.
Yeah. Well, next time I'm in the Valley, I definitely got to stop by.
No problem.
Thank you.
Okay. But thanks, guys. I appreciate it, man.
As we appreciate you guys. Thank you.
All right, thanks. See
All
you
right,
soon.
then. We'll see you again.
All right.